Sir, voice is not audible. Your voice.
Yeah. Is it okay, Vinay? Hello?
Sir.
Yeah. Good evening, everyone. Good afternoon, everyone. I welcome you back to the day 3, lecture 8 on the CAN course on hybrid renewable energy system and microgrids. Now, Dr. T. Vinay Kumar, who is a faculty of yeah. Um, Today Dr. T. Vinay Kumar, who is a faculty of Electrical Department of NIT Warangal. He's going to give a lecture on experimental demonstration of power converter control with DSPACE. Okay. Vinay sir, Dr. T. Vinay sir,
Sir.
you can go ahead of presenting.
Okay. Good afternoon to all. Sir, screen is visible?
Okay, Vinay sir.
Okay. Good afternoon to all. Myself, Dr. T. Vinay Kumar, Assistant Professor, Department of Electrical Engineering, NIT Warangal. In today's session, I will try to explain particularly what is the need of controller, particularly for power converters. By adopting this controller, how we can able to control the RMS as well as average value effectively to meet our requirement. So this was the content of today presentation. I will try to uh, explain what is the need of the controller, how to identify the control objectives. Once you know the need of controller and how to identify the control objectives for particular system, it is not a big deal to implement in DSPACE software. So first off session, I will try to concentrate on what is the need of controller, particularly to control the electrical system. In various application, I will try to explain. Then after that, how to identify the control objective for particular system to system control objectives. Target variables will change. So through this session, I will try to explain how to identify the control objectives for particular system. Same thing, you can adopt this concept, you can adopt to your system, so that it is not a big deal to identify the control target variables. Next, once you decide the control objectives for particular system, then how to meet the customer requirements through this controller. Then after that, I will try to explain control parameter design concept, how to implement in real time. The next important thing is, particularly whenever you want to control the system or whenever you want to improve the dynamic response, only option is you have to adopt closed loop mechanism. Once you adopt closed loop mechanism, important thing is scaling of the sensors, uh, how quality of the feedback signal is so important, right, to control the system effectively. So through this scaling factor, I will try to explain one or two examples, so that you will get more clarity about how to convert analog to digital, digital signal. Your actual system signal is always in analog, so by using analog to digital converter, then after converting the signal, then what are the precautions we need to take, how to amplify the signal, again how to extract the signal without losing any property, right, how to balance the magnitude, each and everything I will try to explain. Then at the end of today's session, I will try to explain simple VBIF method, how to implement the VBIF method experimentally using DSPACE software, right. Next, before starting session, in between, I need to ask important questions to the participants, so that based on the participants response, I will change dynamically. I will try to modify the deliver content based on the if participants respond. If participants are very good, then I will go very fast. If participants are not responding, then I will explain in detail. So my question to the participants, first question is, what is the need of the controller? What is basic need? Anyone? Why controller? Why we need controller? Hello? Sir, participants can answer, sir. They can mute and
To get the desired response, sir.
to get the desired response. Anyone?
To keep things stable, sir.
Stable.
To keep parameters within the limits.
Hmm. Any why controller is required for any system? So, anyone from the participants? What is the need? What is the need of the controller? What is the primary objective of the controller? By you see, if you take any system, whether it is a drive system or grid connector inverter system, if you take any electrical system, by nature all are in nonlinear in nature. Our system, see, if you take any system, right, basically all are in nonlinear in nature. If it is a nonlinear, what is the issue? What is nonlinear? If number of variables are involved in the more, then it is a nonlinear system. If any system is depending on more number of parameter, then simply it is called nonlinear system. So what is the issue with nonlinear system?
Control will be complex.
Control become, it is we cannot improve the dynamic response. Control, particularly in industrial application, their requirement is instantaneous control is required. If you want control the system instantaneously based on the requirement, if actual system is in non-linear, it is very difficult to control. That's why by adopting this control mechanism, what it will do is, step one, it will change the, it will convert the actual system parameter, actual system characteristics from nonlinear to linear. So by adopting the controller, we can able to convert nonlinear system into linear. Once system is linear, then by choosing proper kp and k values, it is not a big deal to control the parameter. It is not a big deal to control the system response instantaneously. See, average, for average control, you no need to taking care. Nowadays there are two things are there. Systems are controlled using two methods. One is based on the average sense and instantaneous sense. So particularly low performance systems, for domestic application, they are adopting this average control methods. Average control method. Instantaneous control schemes, they are adopting for high performance application. Particularly take robotic application, aerospace application, submarine application, or electric vehicle application. They are adopting instantaneous control method. By adopting instantaneous control method, we can able to control the position of the shaft instantaneously. That is their requirement. Wherever high performance is required, instantaneous control is required. If it is their requirement is instantaneous control, you have to adopt control mechanism. By adopting the controller, we can able to convert nonlinear system into linear. This is the primary objective of controller is, we can reduce the order of the system without changing any physical characteristics. By using controller, we can change the mental characteristics of the system without affecting the physical characteristics. Right? Next, in today's session, I will try to take motor, electric motor as a system, so that through this system, I will try to explain what is the need of controller, how to identify the control objectives for electric motor. Then after identify the control objectives, how to meet the customer requirement. Customer requirements are different, please try to understand. There are two things, two important things are there. Customer needs are different, customer needs are different, right? So to satisfy the customer need, as a control engineer, as a control engineer, you have to identify what parameter we need to control for particular system to meet the customer needs. Customer, he doesn't know what is the strength of torque generated by the motor. He doesn't know what is the strength of the magnetizing flux. He doesn't know about the principle also. His requirement is, take EV application, electric vehicle application. His requirement is always, yeah, he is expecting speed. This is customer requirement. To meet the customer required speed, as a engineer, control engineer, you need to take care about control objectives of the electric machine. Clear? So what are the control objectives in electric motor, participants? What parameter we need to target to satisfy the customer need? If you want to satisfy the customer need with respect to electric drive or electric motor, right, what parameter we need to target with respect to control point of view?
Torque requirements.
Torque.
Torque requirements.
Okay. Any other?
Speed.
Currents and
Speed of the
voltages.
machine.
See? Now,
Position.
so I will tell one example so that you will get more clarity. Take electric motor. This session should be like interaction. It is not like, please try to understand. I will simply, don't think I'm teaching, just you have to listen. You have to interact so that the session, whatever session I got, this session we have to utilize effectively, right? So in detail analysis is required to understand the need of the controller. Once you know the, I'm telling, see, so our objective is implementation of method in DSPACE software. Suppose let us that to implement the concept, any concept in real time, let us that we have 1 hour time. Out of 1 hour time, minimum 40 to 45 minutes you have to spend for identify the problem, how to identify the problem and identify the benchmark of the system. Nothing but it is completely analysis is required. 40 to 45 minutes you have to do analysis. So once you get more clarity about the concept and once you identify the problems faced by the actual system, what is the need of the customer, once you get the more clarity about the benchmark of the particular system, right, then implementation, getting idea and implementing the idea, it is not a big deal. So within 10 to 15 minutes we can get the idea. Many scholars, what they are doing is they are unable to get the ideas, right, for a particular topic. Reason is they are not spending effective time for identify the problem. If they spend more time on the literature survey, if they spend more time on the analyzing the existing method in detail in different direction, right, so what they will get, see, they will get what are the issues with existing model. They will get based on the issues. If you analyze the issues in detail, then you will get ideas. But see, scholars, many scholars, what they're doing is they're deciding, once area is decided, once particular area, once area is decided, simply they're always focusing on what is the idea, what idea we need to implement, what idea we need to see, whether whatever idea is proposing, whether this idea is existing or not, they are not bothering about. Reason is they are not, if they spend almost 70 to 80% of time per day for literature survey or existing methods or benchmark parameter, then it is easy to get the idea what so whatever idea you're getting, this idea won't be existing, right? So it is a new idea. If you propose new idea, definitely implementation through DSPACE software nowadays, it is not a big deal. Even DSP also we can access through MATLAB software. Within 1 week we can implement the idea, we can submit and you will get good publication, right? So in today's session, my objective is what is the need of controller for electric motor, how to identify the control objectives for electric motor if you adopt in various application. Electric motor, wherever mechanical energy is required, you can use electric motor. Application is basically motor is a torque. If you take motor, electric motor, it is a torque producing device. What is the input to the motor? What is input? Expected output is torque. What is the input to the motor? What is input to the motor?
Electrical signal, sir.
Voltage. Any other inputs are there for motor?
Output from the converter.
No. Simple take motor. If you take motor, simple take any motor, DC machine or AC machine, how many input signals are there? How many output signal is there? Basically, electric motor is a torque producing device. The expected output of the motor is a torque. Input is electrical force. One more input is there. What is the another input to the motor? That is called load torque. Clear? This is called, this load torque, it is not under your control. This load torque, whatever burden is applied on the motor, this component you need to satisfy. That is the, see, this is not under your control. This is not under our control. This one you have to satisfy. Whatever burden is there on motor shaft, you have to overcome. Then only you will get finite speed. Then only you will get equilibrium point. Right? What is there under your control? Under your control is voltage. Through power electronic module, we can able to control RMS or average value through power semiconductor element. The primary object of power electronic module is RMS and average values. We can control frequency, RMS, average. Based on the requirement, we can control effectively. By controlling the RMS or average value to the motor, we can able to control the torque. So finally, if generated torque is matching with load torque, then you will get equilibrium speed. Right? Next, one more important thing is, say as an electrical scholar, you need to depends on cause and effect. This is a very important concept, right? Cause and effect. Now, say if you depends on the cause and effect relationship, right, it is not a big deal to develop the transfer function model for particular system. Once you know the transfer function model for particular system, it is easy to design the control parameter, right? Control objectives, design of the control parameter, everything is depends on the actual system behavior. So if you want to extract the behavior of the system, here you should know what is the cause and effect relationship for particular system. Based on this cause and this is the, please start understand, this is the main concept to develop the this is the main logic behind to develop the transfer function. Transfer function is nothing but output by input. This is the standard definition you can find in the textbook, but see the transfer function is derived based on the cause and effect relationship. Please start understand. Output is nothing but effect. Input is nothing but main cause for particular transfer function model. Right? Now, see here for understanding purpose, take electric motor. In electric motor, see in today's session we'll take system is a electric motor. If you take why, because it is easy to understand, right? We can easily understand the concept with respect to control point of view if you take simple system. Why? Because there are only 3 circuits are there. In case of electric system, how many circuits are there? How many circuits are there inherently? Electric machine, motor. How many circuits are there?
Armature and field.
Very good. Armature circuit. Very good. Armature circuit. field circuit, right? Next, any other circuits are involved in the motor? If you take any motor, irrespective of the type of motor, irrespective of the number of phases, whatever concept I am explaining, this concept is common for all electrical machines. See, if you take electric machine, finally there are two circuits are there. Three circuits are there. One is any machine, whether it is a DC machine or AC machine, right? Finally, inherently there are three circuits are there: armature circuit, field circuit. Another one is mechanical circuit, right? So, if you take armature circuit, what is the expected output of the armature circuit? What is the expected output? Input is armature voltage, output is armature current, right? If you take field circuit, field voltage is the input, output is field current. Now, if you take mechanical circuit, what is the input to the mechanical circuit? What is the input to the mechanical circuit? What is the input? Mechanical circuit input is torque. What is the output?
Load.
Speed. Load is not output. Please try to understand. It is an input to the system. You need to satisfy the load. Load is acting as an input signal to the motor. Whatever button is applied on the motor shaft, that signal you need to treat it as an input, right? Here this is TL minus TE plus TL, right? So based on, see, once generated torque is matching with load torque, then speed become equilibrium. So what I'm trying to say, highlighting here is, as a electrical scholar, if you know the cause and effect relationship for a particular circuit, we can easily identify what is the nature of the input to the controller, what is the expected of the controller. You will get more clarity about the behavior of the control signals, right? Many scholars, they are unable to identify the, even though they know the type of error, whether error is a current signal or voltage signal or speed signal, but they are unable to identify what is the expected output of the controller parameter, right? They are unable to identify, right? If you take any controller, let us assume that, let us assume that, understanding purpose, take PA controller. What is the input to the PA controller? Always input to the error. What is the output of the controller? It is called cause component. The output of the controller is a cause component. This is called, our aim is eliminating the error. Our aim is eliminating this effect. If you want to eliminate the effect, as an electrical scholar, what is the primary cause component to eliminate this error? You need to analyze in detail with respect to system. If you analyze the cause and effect relationship, right, whenever you want, suppose with respect to armature circuit, your aim is eliminating the current error. Suppose PA controller, if you send the IA error through the PA controller, what is the expected output of the controller? What is the expected output of the controller? It is a VA. Why VA? VA is the output. VA is only component, control component to control the IA error. There are no other parameters. If you take VF, by controlling the VF, we cannot control IA. By controlling the torque, we cannot control IA. Please try to understand. IA is control, armature control, armature current error we can eliminate through VA. Why? Because see, our system, natural system behavior is like that only. With respect to armature circuit, this is called input, this is called output. Output is nothing but effect. This is called cause component. Your aim is eliminating the current error. Whenever you want to eliminate the current error you need to send to the PA controller. If you send the error to the PA controller, what will happen? Your PA controller will decide how much armature voltage we need to maintain across terminal. Your PA controller will decide. If you maintain same voltage across the actual across the terminal of the actual system, in coming sample period, what will happen? Coming instance, this error will come to 0. That is the beauty of the controller, right? So in today's session, I will try to explain how to identify this is about cause and effect relationship. So the same concept you can apply to your system also, right? So definitely we can easily identify the what is the output of the controller. If current if input is, if you know the input signal, we can easily identify the what is the expected output. Many scholars, they are thinking that output of the PA controller is always modulating waveform. That is a standard word. But what is the nature of signal? Nature of signal is here. If you take current, armature current as an error, then PA controller output is always it is a armature voltage reference. It will decide reference armature voltage. Similarly, if you take mechanical circuit, in case of mechanical circuit, what is the output? What is the effect? Whenever you apply the electrical force, what you will get? If you apply
Speed.
force, you will get, with respect to shaft, you will get speed. Speed is the output. So here, if you take PA controller, speed controller, so aim is eliminating the speed error. That aim is omega m error. If you want to eliminate, so you, what is the expected output of the controller? Your controller will decide torque. Clear? This is called torque. Is the main cause component to eliminate the speed effect. Why? What is the reason why torque? What is the main? What is the logic behind this circuit? Why torque is main cause component to eliminate the speed error? Reason is with respect to actual system. See, if you are according to Newton's law, here, if you want change the objective, if you want state the objective, if you want change the state of the objective, it requires force. Without applying the force, objective state is always fixed. It will not change. Once you apply the force, then only x will change. Position will change. Clear? So this is the main cause component. This is the effect. So if you depends on the cause and effect relationship, we can easily identify the transfer function model. This is called transfer function model of the mechanical circuit. This is the transfer function model of the field circuit. This is the transfer function of the armature circuit. So if you take any transfer function model, what is there inside the transfer function model? Anyone from the participants? What is there inside this box? What is there here?
Time constants.
Sorry?
Circuit parameters are represented in the form of time
Yeah.
constant.
See, if you take any transfer function here, it contains the system parameter. Based on the system parameter, right, you will get transfer function model, right? So first step is, what is my request is, first you need to, whenever you want to control the particular system, important thing is, primary thing is, you should know the system characteristics. As electrical scholar, how we can extract the characteristics? Based on the mathematics. Through mathematics, if you extract the system characteristics in terms of transfer function model, it is not a big deal to identify the control objectives. Once you identify the control objectives, it is not a big deal to design the parameter. So first important step is, you need to identify the system characteristics, and then after that, based on the system behavior, based on the system circuits, then you have to develop the transfer function model. Once you know the transfer function model, we can easily design the control parameter, right? See, once your controller is working fine in simulation, then you have to go for implementation. Whatever idea you are proposing, as an electrical scholar, many scholars, they are working on control side only. Only few scholars, they are working on design side, design of the power converters, design of the circuits. Many percentage is very less compared to control engineers. Control scholars are more compared to design engineers, right? So then once your controller is working fine in offline simulation, then you can go for implementation. So after implementation, next testing. This is a very important stage. Many scholars, they are thinking that after implementation our job is over, right? Then whatever results we are getting, and we need to substitute, we need to place in paper, and we need to send to particular journal, like that they are thinking. So this is a very important stage. Testing of the method is very important. And after getting, see before testing, you need to analyze our experiment, our system, at what condition we need to operate, at what condition we need to test. Next, how to extract the quality of the proposed method, also so important in testing stage, right? In testing, before doing testing of your logic, right, you have to predefine at least minimum 5 to 8 questions. You have to write, take paper, and you have to write what test we need to conduct, how to highlight our method compared to existing method. You need to write before doing testing of the results, right? So if you highlight your control concepts, right, um, with respect to recent papers as well as standard conventional methods, definitely chances are more for acceptance of your concept, right? So testing and analyzing is so important, right? If you are not testing properly, if you are not analyzing the your results in detail, compare with recent papers, and it is chances are very less to get acceptance. So, right, so for that, see, if you take any system, what is my suggestion is, first, whenever you want to control particular system or whenever you want to meet the customer requirement, important thing is, see, you have to study the system characteristics in detail. This is a very important. As a control engineer, system study the system characteristics through mathematics is so important before going to control, before satisfy the customer requirement, right? This is very important. You need to study the system behavior in detail. Then after that, see, as an electrical scholar, see, once you know the system characteristics through mathematics in different direction in detail, then after that, it is not a big deal to identify the gaps, right? Any drawbacks, identify the drawbacks, it is not a problem. Once you identify the problems, gaps or problems in a particular system, then immediately you have to think, you have to you have to start the design procedure. You have to think, this is called ideate. You have to think in different direction, whether we need to substitute, or whether we need to adopt some mechanism, or we need to eliminate some parameter control side, like that. You have to think in different directions, so that see, if you adopt some techniques, right, so we can easily generate the ideas for particular system in different direction. Once you get the ideas, then implementation is a very big challenging for electrical scholars, particularly electrical scholars, computer science or other scholars. It is not a big deal. Even if you take electronic scholars also, implementation is not a big deal. But electrical scholars, implementation, while coming in the stage of implementation, our power ranges, signal ranges are more. In that case, see, you need to take care about the implementation. Before doing implementation, see, why? Because voltage ratings are more, current ratings are more. If your controller is not designed properly, definitely actual system will get damaged. Why? Because current, it will go beyond the limit, system will overheated, or sometimes it may get damaged also if you are not taking care. That's why before doing implementation, before starting implementation, see, important thing is, you should know what is the rating of the system. Once you know the rating of the system, see, we can easily adopt the saturation limit for every controller output. So by taking saturation output for every controller, we can protect the system from the heating effect. Once system is protected from the heating effect, it is, say, even kp and k values are, whatever kp and k values you have selected for control the system, it is not a problem, right? So then after implementation, then you have to test your logic. Then if everything, maintenance is everything fine, your system is obeying your order, then it is fine. You can continue this idea, right? So that your system will obey your requirement. Now my question is here, important thing is, now what is our how to decide this is very important before starting. See, whenever you want to control the system, and identification of control objectives are so important. Control objectives nothing but target parameters. How to identify the target parameters for electric machine? Today our example is our system is a our system is an electric motor. In electric motor, see, with customer requirement is, customer need is always position or omega m. These two parameters are very important with respect to customer point of view, right? As a control engineer, to meet this parameter, what parameter you need to control, what parameter you need to target? Speed. How we can get speed?
By controlling torque.
Very good, this is the torque. Next, any other parameter they are targeting? Torque is the primary control objective. This is the primary control objectives in electric machine. There is one more objective is there, that is called flux. This is called flux linkage. Why they are targeting flux linkage also? See, before discussing significance of flux linkage in electric machine, before control the torque, whenever they want to, as an electrical scholar, see, already we got relation between the with respect to electromechanical system, right? See, expected output of the motor is torque. By using this torque, right, if you derive the transfer function model for torque, expected output is speed, omega m. By controlling this component, we can able to control the speed. By control the speed, we can able to control the position. Please try to understand. This is the sequence. This is the hierarchy. We don't have any freedom on this, right? This is the actual system behavior, right? Whenever you want to change the position of the shaft, you need to depend on the speed. By adjusting the speed, right, we can control the position. Whenever you want to control the speed, you need to control the torque. So see, this is the sequence, this is the hierarchy we need to follow. We don't have any freedom on this, right? Now see, these two parameters are so important with respect to customer point. Whenever you want to meet the customer requirement, see, as an electrical scholar, your target parameter is the torque. This we can understand clearly. But my question is, this is the primary control objective is torque. Now question is, why we need to take secondary control objective as a flux? Whatever concept I'm explaining, this concept is common for all electrical drives, all electrical machines, not only for DC machine or not only for AC machine. See, even if you take DC machine or AC machine, their focus is on control the torque and flux always. Anyone from the participants? What is the advantage if you target flux also along with torque? Anyone from the participants? You got my point, participants? You got my question?
Yes, sir. Flux is directly proportional to speed, so that speed can be controlled.
No.
Saturation, motor saturation.
No.
So for precise control, sir,
But precise control of what?
for example, if we want to control the output torque, and if there are some oscillations in the output torques, so by controlling this flux and speed together, is it like that?
Actually, what we are doing here, finally we identify these two parameters are customer requirement, correct? Position and speed. See, if you take electric vehicles, their requirement is speed. In case of robotic application or satellite application, their requirement is, customer requirement is position control. Even if you take nowadays solar panels are controlled through motors by position control logic based on the irradiation, right? So they are extracting the say to get maximum power at any instant, right? So they are adjusting the position through motor of the solar panel so that they can extract the maximum power at any instant of the time. So to satisfy the customer requirement, right, torque is the primary cost component. This component is controlled by the electrical control engineer, right? See, the need of controller, if you take any controller, need of the controller is it will control the, it will eliminate the effect of the error. Any error is there, then immediately controller will decide how much cost component we need to maintain. If you maintain same component, cost component, with respect to actual system, your error will come to zero in the coming instant. Next, this is the our target parameter is a torque. But if you focus on flux controller also, what is advantage is already very popular method. You heard about armature voltage control method for DC machine? Participants, armature control method, you heard about the name control
Yes, sir.
method? Ah, in armature control method, what we are doing throughout the operation?
Keeping field fluxes constant by varying armature voltage.
Field current we are maintaining constant at rated value. We are maintaining field current constant, nothing but here in armature current, the aim of armature control method is control the speed below the base speed. That is the primary objective of the armature control method. Whenever you want to control the speed below base speed through armature control method, as an electrical scholar, as a control engineer, what you are doing is you are maintaining field current as a constant at rated value. See, advantage is if you maintain field current is constant with respect to dynamics point of view, it will improve. That is the beauty of control mechanism. Dynamics of the system will improve. How dynamics of the system will improve? How nonlinear systems will converted into linear by adopting the armature control method. Simple method. I will try to explain so through mathematics so that you will get more clarity. See, now question is, now what I will do is I will take universal torque expression. So here this is called universal torque expression, which is applicable for all electrical machines. This equation is except switch reluctance motor. This equation is not for switch reluctance motor. This equation is not applicable, right? This equation is applicable for induction motor, PMSM machine, DC machine, right? Even if you take IPMSM machine also, this equation is applicable. BLDC motor also, this equation is applicable, except SRM, switch reluctance motor, this equation is not applicable. Now thing is, see, where ZS is nothing but stator flux linkage, there is rotor flux linkage, delta is nothing but space displacement angle between these two, right? If you take this equation, now take for understanding purpose, take DC motor. In DC motor, we are adopting to control the speed below base speed based on the customer requirement. What we are doing is we are maintaining field current constant. What is the advantage of armature control method? I will explain through this equation. Armature control method. Why armature control? In armature control method, why they are maintaining field current constant intensely, right? Through this equation we'll try to analyze, right? The beauty of the DC machine is because of characteristics of the physical system, because of commutator and combination of commutator and brushes, at any instant of the time, stator flux linkage and rotor flux linkage, what is the space displacement angle between these two?
90 degree.
It is always 90 degree. Irrespective of the operating speed or irrespective of the operating load, delta will maintain 90 degree, right? So once delta is 90 degree, is it variable or constant?
Constant.
it is a constant. If it is a constant, then advantage is here the number of variables involved in the torque expression will become 2. How many variables are there here? There are 2 variables, nothing but it is a second order system, right? So is it linear or non-linear system? This equation. Participants, is it linear or non-linear? So this equation we apply to the DC machine. Finally, what will happen? Sin delta become 1. Why? Because delta is always 1 in case of DC machine. Right? Is it linear or non-linear? How many variables are there here? There are 2 variables.
2 variables.
Based on the number of variables, we can decide the order of the system. See, DC machine, DC motor, basically it is a second order system. How to decide the order? Based on the output parameter profile. See, whenever you want to decide the order of the system, you should know what is the expected output of the system. Based on the output parameter characteristics, we can decide the order. We don't have any option. Please try to understand order. How order of the system is depends on the number of variables involved in the output parameter. Output parameter of the DC motor is a torque. So that's why you need to take torque profile for the DC machine. If you take torque profile for the DC machine, finally there are 2 variables are involved in the system. That's why it is called second order system. Is it linear or non-linear? My question is, by nature, it is in second order. Second order system is a linear or non-linear? Participants?
When we
Linear.
keep field flux as constant, then it will become linear.
You forget about field current constant. So
Then it is non-linear.
yeah, this is called non-linear. By nature, all systems are non-linear nature. Once it is a non-linear, then as a control engineer, you need to find the solution. See, at the same time, if it is in second order equation, see, if it is, there are 2 variables are involved in the torque expression. Whenever you want to control the torque through these 2 variables instantaneously, it is not possible. Instantaneous torque control is not possible if it is more than first order. That's why, right? So your job is you need to identify the number of variables involved in the torque expression, particularly in DC motor. Advantage of the DC motor is sin delta become 1 throughout the operation. By nature, because of physical device, nothing but because of commutator delta become 90 degree. If it is 90 degree, then sin delta become 1. So finally there are 2 variables are involved in the system. So even though number of variables are less, it is a non-linear system. So say if it is a non-linear system, as an electrical scholar, how to convert from non-linear to linear without changing any circuit? Physically, you should not touch anything. We don't have any freedom. Once you purchase machine, we cannot do anything on the physical system. Only thing is, by adopting the control mechanism, right, we can change the characteristics of the system. We can change the behavior. Your physical system will obey your order through control mechanism. What is that control we are adopting? That is called armature control. In armature, this is called method. It is a scheme, control scheme. It is a mathematical concept, right? By adopting this control scheme, right, throughout the operation, what they are doing is they will maintain field current constant. If field current constant, what will happen from this equation? Second order system become, if field current is constant, then torque is directly proportional to Zr. Zr is nothing but torque. It is a function of, Zr is function of armature current. Now see, finally what will happen after adopting armature control method? It is a scheme control method. What will happen? Second order system become first order. So by controlling the IA, we can control the torque instantaneously. So it is called linear system. Now tell me here, what is the advantage of control method? Control method primary objective is it will change the order of the system. Once order is changes, definitely dynamic response will improve compared to natural system. Without controller and with controller, main difference is dynamic response. Dynamic response is different. After adopting armature control method, what will happen? Dynamic response of the torque will improve. Why? Because it will converted. This method will change the order from second order to first order. So this current, by controlling the IA, we can control the torque. IA, how we can control IA? How we can control IA?
By controlling voltage.
By control the voltage, armature voltage. This IA we can control through VA. How we can control VA? Practically, this VA is controlled through power semiconductor modules. Power semiconductor module, nothing but power semiconductor modules are controlled through duty period. Duty period is under your control. This duty control, this how much duty of the switch will decided by the control scheme. Whatever control scheme you are adopting, see, finally the main object of control scheme is it will decide the duty period of the switch. By decide, see, once duty period of the switch is decided by the controller based on the customer requirement or based on the error signal, definitely, right, your see, based on the duty, power electronic module don't have any freedom. Whatever duty signal is coming from the controller, simply power electronic module proportionally it will generate the voltage and frequency. If you apply this voltage and frequency to the actual system, what will happen? Immediately current will regulate. Once current is regulated, immediately torque will regulated. Then if torque is changes, speed also will regulated. If speed is changes, position also will regulated based on the customer required. So this is happening in electric drive mechanism. This is about significance of the control scheme, right? So first off session, I will my concentration is need of the controller, right? What is the significance of the controller? What is the need of controller? Need of controller is by adopting the control mechanism, we can able to improve the dynamics of the actual system. Whenever you want to improve the dynamics of the system, you need to adopt particular method. By adopting armature control method, it is a scheme, right? We can able to improve the dynamic response. We can increase the dynamic response of the torque. That's why whenever you want to control the torque, whenever you target the torque, right, proportionally you have to target field also. You have to maintain field as a constant. If you maintain while control the torque, whether it is a DC machine or AC machine, while control the torque to meet the speed requirement by the customer or position requirement by the customer, right? We don't have any option. You need to maintain field current constant. If field current maintain constant, advantage is torque control becomes simple. Number of variables involved in the torque equation will simple. So burden on the processor will coming less. If burden is less, execution time is less. What is the advantage? If execution time is less, what is the advantage, participants? If number of variables are less, if number of feedbacks are less, what is the advantage? If execution time is less, what is the advantage?
The controller will be faster.
If execution time is less, sample time you can take very less sample time, right? Sample time is decided by how much sample time we need to take while executing our logic is decided by the execution time of the logic. If your logic is very lengthy, then problem is execution time will increases. If execution time, suppose example, right? Suppose there are two students are there in the class A and B, right? Target is 1000 RPM. To meet the 1000 RPM, they have developed the armature control method logic in C program, right? Suppose for A student execution time is 100 microsecond. Execution time for B student execution time is 10 microsecond. Then what is the problem? See, for A case, he cannot take sample time delta t or ts less than 100 microseconds. At least he has to take 150 microsecond. But B case, he can take sample time delta t, he can take 20 microseconds or 30 microseconds. So if number of samples per second is more, what is the advantage? Accuracy, control accuracy will increases. Accuracy will increases. That is the advantage. Let us on that take thousand milliseconds. This is a total our time slot, right? Here we can take 100 samples. With respect to B case, B student, he can capture 100 samples. So 100 times he can iterate his sample, iterates his logic, right? But here A student, only 10 times he can iterate his logic in 1000 microsecond slot. Available slot is 1000 micro. This is total period, total time period. This is a complete task period. Advantage of the B student is here he can execute the program with less time. If what is the advantage is, if execution time is less, right, you can minimize the sample period. If sample period is less, advantage is we can take more number of samples per period. If you take more number of samples per period, advantages we can rectify the error. Let us assume that see, most of the engineering colleges, what they will do per semester, for 6 months semester, how many times they are taking feedback from the students? Feedback, how many times they will take per semester? Are they only one time? Am I correct or not? At the end of, before end examination, they will take feedback from the students, how faculty is teaching, how faculty is conducting examination, what is the quality of paper. Based on different parameters, they will take feedback, right? What is the issue? What is the issue if you take only one feedback signal from the students for one semester? Is there any use for this feedback for current students? Anyone from the participants?
Not at all. Not at all useful because anyway time is gone.
If you take more feedback before minors, before minor examination, before mid examination, after mid examination, before laboratory examination, before end examination, after end examination also, what is the quality of the paper? If you take more feedback, more feedbacks, more number of samples per semester, advantage is any issue is there in minor one itself, before minor one itself, right, we can rectify the issue. If number of samples are more per particular period, definitely we can eliminate the error. That is the advantage of sample period. But sample period, please start to understand, it is not under your control. Sample period is decided by the length of your program. A student and B student target speed is 1000 rpm. Their requirement is same, but A student is unable to write the logic with less number of instructions. But B student ability is able to write the logic with less number of instructions, so that he can take more number of samples, right? If execution time is less, he can take more sample. That is the advantage. As electrical scholar, many scholars, they are thinking that identify the problem, and after getting idea, then our research work will completed. While implementing, how much quality you are taking care about the execution time is so important, right? If execution time is increases, definitely performance will degrade. If execution time is more, right, we cannot take more, we cannot improve the switching frequency of the power electronic module. The main object of today's session is experimental demonstration. See, if you want to understand the before doing experimentation, as an electrical scholar, see, you have to think about three things. One is controller, another one is actual system, right, another one is feedback, right? These three things are very important. Actual system, basic, see, whatever system you have taken, you should know in detail behavior of the system. Once you know the in detail behavior of the system, then we can easily identify the control objectives, right? Based on the control objectives, we can easily decide the feedback signals, right? So while implementing in the logic, important thing is execution time. How much time is taking to execute your logic is so important in real-time application. So through DSPACE controller, advantage is the object of DSPACE controller is we can see it is many scholars they're thinking that DSPACE controller will give solution. Please start understand. It will not give solution. You know about calculator? What is the purpose of calculator? What is the purpose of calculator?
Yeah, doing some mathematical calculation.
It will give value, right? So to get, see, calculator will execute your inputs. It will execute your requirement. A plus B or A minus B or A into B. See, as a electrical scholar, see, if you want to use calculator, you should know what is A value, what is B value, which operator we need to use at particular point is so important, right? Similarly, DSPACE controller, every controller, see, whenever you want to access the controller or whenever you want to execute your logic through controller, important thing is you should your controller will give only result. Only it will give, this is result. Your calculator will give result. Even in DSPACE controller also, it will give, any controller will give only result. But as a scholar, you have to write the program. You have to write the logic in detail, right? You have to give inputs to the system so that your controller will give only result. If there is any problem with results, many scholars they are thinking that our controller is problem, like that controller, it is not, it will not create any problem. See, as a scholar, if suppose output is, your results are not matching with your requirement, immediately you need to check your logic. You need to take care about your program. If you concentrate on your program in terms of mathematics, in terms of transfer function model, whatever program you have written to control, to execute your concept, right? See, whatever value is coming, it is not matching with your requirement mathematics, you need to change the parameters, you need to change your inputs, right? Calculator, it will give 100% correct value on if you give proper input. Similarly, these controllers also will work fine, right? Except some of the cases, what will happen, sometimes your ADCs will get damaged because of if you give input voltage more than 3 volts, definitely ADCs will get damaged. All controllers maximum voltage range, operating voltage range is less than 5 volts, right? Whatever feedback signal, analog signal you are taking, that analog signal value is greater than 3 volts, your ADCs will get damaged, IO pins will get damaged. That's why you need to take care about feedback signal voltage levels and current levels. Current and voltage level should be less than 5 volts, like that. See, you need to take care, right? Particularly see, advantages, particularly in today's session we are focusing on DSPACE controller. See, we are not here to publicize the DSPACE model here. Please start to understand, this is see, we are adopting DSPACE controller to explain the control method, how to implement the control method through DSPACE. We are focusing today, but we are not here to publicizing the DSPACE controller. Please try to understand. So we are not recommending DSPACE also. We are here to explain the concept control, what is the significance of controller, particularly in electric drive mechanism, how to implement simple VBIF method to control the speed of the system through DSPACE software. I will try to explain. Clear? You got my point, what I'm trying to say, participants?
Yes, sir.
Yes, sir.
Yes, sir.
So here, this is about overview of the propulsion system, EV propulsion system, right? So these three are very important things in the EV propulsion system, right? So aim is control the speed. Our customer requirement is, with respect to customer requirement, always speed is their requirement. To meet this required speed, you need to take care about how much torque generated by the machine, whether it is a DC machine or induction motor or SRM machine, PMSM or permanent magnet hybrid machine also, right? Irrespective of the type of motor, right? you need to take care about what is the strength of torque generated by the motor based on the required speed. If you want to satisfy the customer required speed through torque, right, here you need to take care about voltage and frequency generated by the power electronic module. Power electronic module, eh, uh, it is controlled, it is completely controlled by the duty period produced by the control circuit. Under control circuit, there are two things are there. One is software side, another one is hardware side. Hardware side, we cannot do anything. Please try to understand. Software side, see major work, many scholars they are doing on the software side. They will try to develop the different logic, hybrid PWM methods or multi-level PWM methods for multi-level inverters, speed control techniques, model Peter control method, direct arc control method, or hybrid hybrid PWM methods. There are different control methods are coming under software side. Software side is nothing but logic, control logic. Even armature control method also coming under software side, right? So once you develop the logic through mathematics, then this mathematics you have to execute through controller, hardware, DSP or microcontroller or microprocessor or FPGA boards. Through these boards we have to, but issue is, problem is, whenever you want to access the DSP, right, important thing is you should know architecture of the DSP. See, problem with scholar is there is a 3 years limit is there to get the stipend, or to even if they want recommended for fourth year also, challenging is at least you have to publish 1 or 2 papers within the 3 years slot, then only they will recommend for extension, right? So our slot is so with so many slot dead, our critical time period is 3 years. Within 3 years you have to get minimum 1 paper to for extending the research work or getting stipend for 4th or 5th year, many universities. In that case, what will happen, whatever existing softwares are there, through existing softwares, if you want to execute your logic, say whatever hardwares are there, if you want to access the hardware within 3 years, and if identify the problem will take minimum 6 to 8 months, right? This is happening for every case. Most of the students are facing this type of, they have to go through this literature survey, minimum 6 to 8 years, 8 months they have to do literature survey. Based on the literature survey, they have to identify the problems. Once problems are defined and target benchmarks are defined, then they have to find the solution. Getting solution, it is not a simple, at least minimum they have to work 6 to 7 months, right? Whatever idea is coming, then whether it is feasible or not, they have to think, right? In prototype only they will get clarity. What, see, every idea will not work in it will not works most of the time. Whatever idea they are proposing, sometimes it may fail also. Experimentation, simulation side, it will work. That's why once later on that, even your idea is very good, to implement in DSP, it is not a simple task. Again it will take to understand the architecture of the DSP itself, it will take more than 6 months. That's why DSPACE software they have proposed, right, to minimize the execution time, to minimize the implementation, to develop the, whenever you want to develop the prototype model, right, whenever you want to test your idea through prototype, right? Clear? So here they are proposing, they propose DSPACE software. In DSPACE software, front end is MATLAB window. So through MATLAB, see, MATLAB is a very user friendly, right? See, front end program is MATLAB, back end program is this. MATLAB is integrated to the DSPACE software. DSPACE software is integrated to the microcontroller plus DSP processor. Finally, there are two inherent, there are two processors, two controllers are there. One is DSP, another one is microcontroller. This is called master. DSP is acting as a slave processor. So finally, controller will produce the control pulse. The expected output of the controller is gate pulse. See, executing the logic, identify the problem is a very big challenge. Once you identify the problem, finding the solution also another challenging. Next, after getting idea also, implementation is a very big challenge. That's why, see, if you adopt this DSPACE software, advantage is implementation time become very less. Right? Now, can I ask one question? What is prototype model? Why prototype model is required? Anyone?
Just to get a feel, I mean, before we can go for actual, I mean, industrial production or sort of, mass production,
That
we
is
can
fine.
make a small,
Yeah.
we can
So
make a
later
small
we can scale
prototype
up.
and
Uh,
and understand whatever we are thinking, whether that will work or not in the real environment.
See, as a controller, you know, right? Your logic is working simulation, right? Then as a controller, you know the effective of your proposing method through simulation. Also, we can identify. But my question is, what is the need of prototype? Whether it is a small scale prototype or rating is same as practical. Also, you forget about small scale or large scale. What is the need of prototype? After developing the prototype, what is the next stage? Testing. Clear? This is what we are doing. Now question is, there is a standard definition is there for prototype. What is prototype? There is a philosophy is there is a concept is there behind this prototype model. Through this prototype, actually through idea, see, before prototype, what is the stage? That is idea, generating idea, right? Clear? Am I correct or not? See, deciding the area is the first stage. After that, based on the area literature review, you will get problem statement. This is the second stage. Based on the problem statement and target benchmark, right? Then the problem statement and benchmarks are second stage. Then generating the idea is third stage. Implementation is fourth stage. Implementation and testing is fourth stage. Now my question is here, what is the need of prototype? As an electrical scholar, as a design engineer, why we need to test our logic always through prototype? Why we cannot in literature, why research journals, they are not accepting simulation results? Why they are not accepting your ideas in terms of simulation? Through simulations, they are not accepting. Particularly for engineering, power engineering scholars, it is difficult to get the paper through ideas are in simulation form. They will not accept. If ideas are in prototype, they will accept. What is the reason? What is prototype? At least one participant, at least you can try, no issue. So whatever one participant just now he explained.
It's a real working model, no?
Real working model. Okay.
Or we can say a research product which we generate from the ideas.
Laboratory scale model.
That is fine. It is a laboratory scale model. If you want, later we can extend same concept. We can implement for high large scale also. That is fine.
It's a proof of concept.
Proof of concept.
While
Actually,
doing it in simulation, we can expect some output, but while coming in hardware part, we may not get the same output. So to ensure whether we are getting the same outcome or not, for that only we are going for a prototype.
yeah, exactly.
Reality of your idea.
See, I'm accepting. Accepting your response. So, see, there is a one philosophy is there behind to develop the prototype. Prototype is only method to communicate the customer through your ideas. Whatever ideas you are developing, if you explain your ideas through mathematics or through simulations, normal persons cannot understand. Customers, they cannot understand your ideas in terms of mathematics, or customers, they cannot understand your ideas in terms of simulation. You got my point? If you explain, if you demonstrate your ideas through prototype model, prototype is nothing but it is a it is a it will provide communication between the researcher, designer, and customer. It is a communicator. It is a mediator. It will provide the communication. See, if you develop prototype, customer he can easily understand the effectiveness of your idea. Am I correct or not? Clear? If your idea is working fine through prototype, customer will feel, definitely he will get more clarity about what is the effectiveness of your method. How much torque is generated, any vibrations are there in motor through your method. If with existing method vibrations are more, noise pollution is more, noise is more, definitely he will feel, right? Otherwise, by using your method, by using novel method, if vibrations are less, noise is coming very less, definitely he will feel. So this prototype will provide the communication between the engineers and customers. Without prototype, we cannot satisfy the customer. We cannot explaining our feelings to the customer, right? uh, Through mathematics. If you want to explain your, if you want to highlight the novelty of your method, or if you want to highlight the contribution of your work to meet the customer requirement, through prototype only it is possible. That's why all research articles, they are giving top priority for prototype. If your model is working prototype fine, definitely user will feel the effectiveness of your method, right? Prototype will provide the communication, right, between the customer needs and control engineers. Now you understood what is the need of prototype. It is a mediator. Customer can understand the effectiveness of the proposed idea through prototype only, no option. If you show the simulation results to the customer, he cannot understand. Even if you tell customer through mathematics also, he cannot understand. If you explain the effectiveness of your method compared to other methods through prototype model, definitely he will satisfy and he will accept your idea. That's why all research articles, they are giving top priority for whether ideas are testing through prototype or not. They are verifying. Once your idea is working through prototype, right, then it will work in real time environment also. Even though it is a small scale or large scale also, then definitely it will it will reach to customer needs, right? Participants, you got my point? Understood?
Sir, yes, sir.
Clear?
Yes.
Okay. That's why research articles earlier, before 2000, before 2010, most of the journals, they were accepting simulation concept. But nowadays, without prototype model, they are not accepting. Why? Because they are keeping mind in the customers, based on the customer requirement, whether ideas are implementing through prototype or not. They are checking. If everything is fine, then if your idea is working fine through prototype, right, immediately they are accepting. If everything is novelty is there, it is working fine through prototype, they are accepting, right? So our next, this is, as a control engineer, see, whenever you want to implement your logic to the system, important thing is you have to develop one ranking card. See, our today's session is, our main objective is controllability. How to decide based on the torque profile, particularly motor application, based on the torque profile they will decide controllability is nothing but number of variables involved in the torque expression they will decide. So with respect to DC motor, it got 5 out of 5. Induction motor got 4 out of 5 PMSM. Why AC machine? These all machines got less points with respect to controllability compared to DC machine. AC machines controllability is poor compared to DC machine. What is the reason? In case of AC machines, number of variables are more. If number of variables are more, it is very difficult. That's why. But if you take practical application, most of the industrial drives, most of the electric vehicles, most of the aerospace application, electric drives in aerospace applications, submarine applications, they are using AC drives only. What is the reason? Reason is physically AC machines are very good. So all industries, top priority is they will give top priority for physical characteristics. Please try to understand. This point is common for any system, any engineering. Or see their top priority is physical behavior. Sorry, physical characteristics. Once physically system is fit, right, then they will see the mental profile of the system. This star profile is, it will come under mental characteristics. So compared to DC machine problem is physically very poor but mentally very strong. But AC machines are physically very good but mentally very poor. That's why, right? So their priority is, if physically it is very fit, what is the advantage? If system is physically fit, physically very good but mentally very poor, right? So industry, they are giving priority for physically. If first they will see whether system is physically fit or not, they will see maintenance is required or it will occupy very less space or not, they will see what is the lifetime of the system, they will see, right? So here AC systems, AC motors physically very good, no brushes, no commutator, particularly for induction motor. Even if you take PMSM also, no brushes, no commutator, right? So no brushes, no commutator, no speed limit. You can increase speed. Even BLDC motor, you can operate the speed more than 10,000 RPM also, no mechanical constraint, right? There are a lot of advantages are there for AC system, but issue is controllability. With respect to controllability part, it is a very big challenge for system, for control engineering. So how we can overcome this? How we can overcome these problems? How we can improve the mental profile? Mental profile is under your control. Control engineer, right? By adopting the control, by adopting the control scheme, plus by adopting the power electronic model. These two combinations, please start understanding. Without taking power electronic model with, see anyone. So if you want to take only control mechanism, it is not possible. Only option is you need to take combination. By taking the control scheme with power electronic combination, we can improve the mental profile of the system. That is the beauty of power electronic module and mathematic technique. That is the strength of control scheme as well as power electronic model. By adopting these two, we can improve the characteristics. So here, that's why here whenever you want to improve the profile, important thing is, what is the challenging is, you need to take care about nonlinear. How many variables are involved in the torque expression? Output parameter is so important. If number of variables are more, if number of variables are more in output parameter, definitely your job is become more complicated. Number of control circuit become more complicated. This is the issue. If circuit become more complicated, execution time become increases. If execution time is more, definitely steady state performance will degrade. These two are interlinked. These two are interlinked with output system characteristics. That's why, see, if you focus on actual system characteristics, how to minimize the order of the actual system characteristics without changing the physical system parameter. If you focus on this concept, output parameter expression, our job becomes simple. That's why, see, whenever you adopt AC system in industrial application, right, big challenging is identify the system characteristics and eliminating the nonlinear component. These two are very big challenging. Developing the accurate mathematical model also very big challenging for engineers, control engineers, right? See, good thing is nowadays we have mathematical model for most of the system, electrical system. See, once you're having mathematical model, it is not a big deal to understand the behavior. Once you understand the behavior, right, in detail, we can easily control. See, that's why nowadays we are following this procedure. This is the standard procedure they are adopting for AC systems, right? So first important point is, first you need to understand the system behavior based on the mathematics. Through mathematics you have to understand. That's why mathematics, it is not a subject for electrical scholar. It is a language. Each and every concept in electrical engineering you have to understand, or you need to analyze through mathematics. If it depends on the mathematics, our problem become simple. We can easily understand the behavior of the system. We can easily draw the characteristics. Any gaps are there, we can adopt, right? So this is a very important point, primary stage. If you want to overcome the above challenges, if you want to overcome the above challenges with respect to AC system, right, you need to depends on the mathematics. Another important thing is transformation technique. Participants may know the what is the need of transformation techniques in electrical engineering. Most of the engineers, if your system is a three-phase system, what, right, we are adopting transformation technique. Now my question is, what is transformation technique? What is the logic behind this transformation technique? What is the philosophy behind this transformation technique? Anyone? What is the need of transformation technique? Tell me first.
To convert this AC signals to DC platform.
That is a method. That is the procedure. See, in transformation, procedure is you have to adopt transformation technique. By using transformation technique, we can convert three-phase variables to two-phase. That is fine. Need. I'm asking need. I'm not asking procedure. Procedure is different. Need.
To understand the dynamics of the system.
To understand the dynamics of the system. Very good. Then what is the advantage if you know the dynamics of the system?
Computation become easy.
We can see, once you know the information through this transformation,
Controlling will be easy.
control become easy. The primary object of transformation is getting information. This is very important. That's why, see, this is the engineering technique, right? What is the application of this? Is called corner mirror. Most of the, see, in metro cities, they are adopting this corner mirror, particularly in parking areas, or or if you take hill areas also, wherever sharp curve is there, they are adopting this mirror, right? So see, later on that, this is our reference vehicle. Our reference person is sitting in the A vehicle. There is opposite vehicle is coming. Let on that, this is the B vehicle. So with respect to this reference person, what he will do, he will see, whenever he want to cross this area, right, what he will do, he will observe he will depend on the mirror. He will get the information from the mirror once, right? So through mirror, what he will get, what is there, he will get information about opposite vehicles. Clear? Am I correct or not? He will get information about what are the vehicles are coming oppositely. He will get information. So if any opposite vehicles are there, any vehicle is coming in opposite direction, then what he will do? Reference person, next stage. First he will get information through this mirror. Next, what is the next step? This is the primary function. This is the primary object of this mirror. First, it will give information about the opposite. Based on this information, controller, what he will do, reference person, he will control the speed. If any vehicle is coming oppositely, he will reduce the speed and he will go very slowly. Otherwise, there are no opposite vehicles, then he will go with increased speed, so that we can make our operation effectively without any accidents, and also we can reach our destination very fast. So at the end, we can minimize the execution time. If execution time is decreases, what will happen? What is the advantage? Already we discussed. If execution time is decreases, we can take more number of samples. Clear? We can minimize the error effectively. We can control. So here, the beauty of this transformation is, this transformation, without losing any property, it will give information in terms of two-phase variables, right? That's why most of the electrical scholars, they are adopting this transformation technique, Clark Park cross transformation technique. See, our systems, most of the cases, our systems, AC systems are in three-phase nature. By using these three-phase signals, we can able to calculate. Let us that take induction motor understanding. If you by taking induction motor, right? By taking these three-phase variables for induction motor, we can extract the torque profile. Then, if you extract the torque profile, you will get this torque. See, by adopting the Clark transformation, three-phase to two-phase variables also, right? Using these two-phase variables also, we can extract the actual system behavior with the two variables, right? Instead of taking two variables in AC nature, by applying the power transformation, right? Two-phase AC variables will converted to two-phase DC variables, right? Using these two-phase DC variables also, you will get same information. In all cases, whatever information you want to extract, right, you will get same information. The limitation with three-phase system is number of variables are more in the three-phase, right? If number of variables are more, right, getting information will become delay. This is a very important point. Delay, if there is any delay in the getting information, definitely we cannot rectify the error immediately. If there is any delay is there between feedback signal and control signal, more than one sample, definitely your error is completely under your control. This is a very big challenging for electrical scholar whenever they want to see delay. There are so many papers are there in literature. They are proposing different methods for delay compensation methods of the feedback signal, right? So whatever signal you are extracting through voltage sensors or current sensors, here you need to take care about delay circuit. Any delay is there, definitely, right? Getting information is delay, definitely error will decrease. Error, it is uncontrolled. That's why you need to take care about delay compensation circuits also. Right? Next, come to here. So even if you take natural system also, we can get same information.
Vijay sir,
Sir.
Sir, how much it takes time, sir?
Sir, now, okay, I will. Can I start how to implement in DSPACE using simple method? Participants, can I stop here? Participants.
Yes, sir. If you can directly move to the DSPACE part, then it will
Yeah.
be easy out of time.
Yeah. So see here, just 1 minute. Within 1 minute, I will wind up this session. See, even if you take three-phase variables, we can extract same information. With two-phase variables also we can extract. See here, same information we can get with different nature of the signals, right? That's why it is called transformation technique. Transformation, nothing but we are see, through this transformation, what will happen, what we are doing is, without losing information, we are transferring the signal nature. Three-phase AC signals we are transferring to two-phase DC signals, right? Even though you are transferring the signal nature in terms of DC also, there is no missing in the information. That's why it is called transformation technique. These transformation techniques are so important whenever you want to control the three-phase system, right? Particularly power quality application or electric drives application, right? Microgrid application. These transformation techniques are so important. Now come to how to implement this logic in DSPACE controller. So particularly in DSPACE, what is there exactly, I will explain. See, DSPACE, this is the structure of the real-time programming. See, this part is coming under control side, right? This part is actual, this is about our actual system, right? So how we can communicate the controller and through actual system? Our controller is always in digital platform. Our system is always in continuous form. That's why through ADC, right, we can give the feedback. Then after that, through DAC, we can give the command to the system. These two are very important points. See, whenever you want to give the information to the controller, ADCs are required. From the controller will decide the command, how much voltage or how much current we need to maintain in actual system will decided by the controller. That's why through DAX we can able to generate the command to the system, so that your system will obey your order based on the error, right? So this is the standard structure for any real-time program. If you want to implement program through ADCs and IO pins, it is possible, right? In DSPACE, so this is the complete R&D control board for DSPACE 1104, right? Here there are two controllers are there. One is microcontroller, another one is DSP controller. Here this is about DSP controller, this is about microcontroller. Most of the cases this is called master controller, this is called slave controller, right? Most of the cases we are adopting master controller only. Whenever you want use some special application, PWM pulse generation application, you can go for DSP process. This is complete architecture of the DSPACE 1104 model, right? So finally here 4 channel ADC side, there are 4 channel 16-bit and 4 channel 12-bit ADCs are available, 8 channel 16-bit DACs are available, 2 encoder. What is the purpose of encoder? What is the purpose of encoder? Particularly for drives application, by using this encoder we can get the information about theta. Clear? Next, 20 digital IO pins are there, IO pins. So the out of this 20, based on your requirement, based on the situation, you can use these pins as an input port as well as output port. Only thing is you have to define whether it is input port or output port. You have to define in program itself, so that it is easy to decide, right? Next, come to this is about dongle. This is about license dongle, nothing but this is like key. Without this dongle we cannot access the controller, we cannot access the DSPACE controller, right? Once you purchase this DSPACE controller, they will provide this key, right? This key is we can this key is only using this key we can access only particular controller only. This key is not universal key, right? This is complete control panel. This is called output and input panel. So this is about ADC panels, ADC connectors, DACs, right? This is about digital IO pins, and this is slave PWM. If you access microcontroller, master controller, you right through these pins we can get information, or if you want you can give the information through digital IO pins. If you activate my DSP processor through PWM pulse, through this pin you can access, right? So these are all the LED indicators for particular pin or particular port. We can easily recognize these LED lights will give what are the pins or what are the ports are actively involved in the program. It will indicate. Suppose here there is IO one pin is there, LED lights is there. If it is blinking continuously, nothing but IO pin is actively working, IO pin pulse is generating, like that we can recognize, right? So this LED light, using this LED lights we can get function of the pins. Next, this is about scaling of the sensor. How many participants know the scaling of the sensor? If you know the scaling of the sensor, then I will skip this slide. If you don't know, then I will explain. Based on your requirement, based on your need, I will continue. You know about how to develop the scaling circuit, participants?
Sir, you please continue, sir.
You know about scale. If you know scaling, then I will scale. If you don't know, then I will continue.
Please explain briefly.
Okay. See, the scaling circuits or scaling factor, it is scaling nothing but it is a multiplication factor. It is simple gain. This gain is so important while converting the signal from analog to digital. Whenever you want to convert analog to digital, see, we cannot simply by connecting analog signal to digital, you will not get digital signal. Only don't think analog signal is directly converted. Before that, you need to take precaution. What precaution we need to take here? By taking simple tachometer. Why? Because tacho generator is very familiar to many people. That's why through tachometer I will try to explain. So what is the function of tacho generator? It will produce the voltage. The output of the tacho generator is a voltage. It is a generator. Input is torque. It will produce twisting force to the tachometer. Then tachometer will rotate, right? Then it will produce the voltage. So here, because of this force, you will get speed. Based on the speed, tachometer rating is for 1000 rpm. Let us assume that this is the rating of the tachometer. If tachometer is rotating with 1000 rpm, right, expected output is 50 volts. That is the nature, that is the characteristics of the tachometer. If input speed of the tachometer, our aim of the tachometer is sensing the motor speed. Through tacho generator we can sense the speed and we can give the feedback to the controller. Whenever you want to give the speed feedback to the controller, see, we can use tachometer, right? So finally, let us assume that see, but our ADC rated voltage is less than 5 volts. You should not give the input voltage to the ADC more than 5 volts. So here, what is happening here? Tachometer, it is converting 1000 rpm to the function of tachometer is it is converting 1000 rpm to 15 volts, 50 volts, right? This 50 volts, you have to step down less than, let us assume that, what is the maximum rated speed? 1440. Let us that we'll design the scaling circuit with respect to rated value only. Please start understand. So our rated speed of the shaft is, maximum speed of the motor is, here motor, AC motor, maximum speed of the motor is 1420 rpm. If machine is running with rated speed, so rated voltage is 71 volts. If you want, you can calculate. See, for 1000 rpm, 50 volts. For 1420 volts, what is the voltage? If you calculate, it will give 71 volts. So if it is a 71 volts input, what is the maximum rated voltage of the ADC? You should not go beyond 5 volts. That's why here you have to use potentiometer. You have to design the potentiometer circuit. So here we can drop out of 71 volts. Here we can block 5 volts here, remaining 60. How much here remaining? How much block you need to block? How much voltage you need to block with respect to R1? R1 voltage drop. How much? Here 5 volts. Our requirement is fixed. Here this voltage is fixed. ADC voltage should not go beyond 5 volts. So like that, you have to design R1 and R2 parameters. So here what we are doing is we are stepping down the voltage from, using this potentiometer, we are stepping down the voltage from 71 to 5 volts. Next, one more thing is ADC also having its own gain. Whatever ADCs they are adopting in DSPACE, it is also having its own gain. What will happen if it is a 1? See, it will step down the signal by 1/10. It will multiply. ADC, what it will do is it will convert whatever input signal is coming, it will multiply with 1/10. So ADC gain is 1/10. So here, how much signal you will get? Tell me here finally. Let us that our speed is 1420 rpm. If it is 1420 rpm, tachometer, it will give 71 volts, right? If it is a 71 volts, the voltage across the R2 is 5 volts. If 5 volt is the input to the ADC, then ADC output is 0.5 volts, right? Then this is nothing but 0.5 is in digital form. It is a digital signal. Now question is, now here this is our controller. Our controller part is here. Now how to get, how much gain is required? How much gain, how much value we need to multiply, right? See here what we are doing is we are protecting the ADC. At the same time, we are sensing this speed signal through tachometer. Tachometer will not give speed directly. It will give voltage, speed information in terms of voltage. As a controller, this voltage, before giving this 71 volts to the ADC, right? Before converting voltage signal to the, in terms of speed signal, you have to step down the voltage signal less than 5 volts, right? By using potentiometer, we can step down. Next, this 5 volts, the nature of the ADC is it is also having its own gain. The gain of the ADC is 1 by 10. See, whenever you are using ADC, right, in real time controller, in experimentation, you should know what is the gain of ADC. See, without knowing the gain of the ADC, it is very difficult to decide the scaling factor for the speed signal. Now here 5 volts, so 520 volts here, 71 volts is the output. Input to the tachometer is actual speed of the motor. Assume that 1420 rpm. Then DSPACE output is digital signal is 0.5 volt. 0.5 signal is 0.5. Now question is how we can get, what is the multiplication factor is required here, how much gain we need to take to convert this signal, the output of the ADC to 1420 rpm. That is the question. How much gain is required here? How we can convert? Participants, how we can calculate based on the multiplication factor for each stages. Here this is one stage. Here this is the first stage 1. This is stage 2. There are 3 stages are there. Before converting speed signal, analog signal into digital signal, so we are adopting 3 stages. By using these 3 stages, we are getting the information in digital platform. Then after getting the signal in digital platform, then you need to decide, as a electrical scholar, you need to identify how many stages are there before extracting the information. Our aim is getting the speed signal, NR. What is the actual speed information you want to get through digital signal, right? First step is you should know how many stages are there in the circuit. So tachometer is there. This is one stage. Now here, what is the multiplication factor here? So here 1420 signal is converting into 71. What is the factor here? How much? 1420 by 71. Here you will get 1x. Clear? So next 71 is converted to 5. So what is the gain of this one? 5 by 71. Here 71 by, so then 1420 is converting to 71. 71 is converted to 5. 5 is converted to 0.5. So whatever signal is, see, whatever procedure is there to convert the signal in each stage, here you have to do reverse process. If you apply reverse process, then you will get gain of the system. So here how to get this one? This is x1. 1420 by 71 is x1 here. Next 71 by 5 is, this ratio is x2. Next 5 by 10 is, sorry, 10 by 5. Output is 0.5. Input is 5. Nothing but output is 0.5. Input is 5. This is x3. If you multiply x1 into x2 into x3 with this signal, what will happen? Whatever signal is coming here, then you will get, this is about, finally if you multiply x1 into x2 into x3, you will get 2840. If you want, you can verify through calculator or mobile. You will get this value according to the scaling of the each stage, right? If you multiply x1 into x2 into x3, right, you will get 2840. If you multiply 2840 with 0.5 signal, then you will get 1420 rpm. Clear, participants? You got my point?
Yes, sir.
Yes, sir. Yes, sir.
This is the way of extracting the speed information in digital platform, right? So here scaling factor is nothing but, this is called scaling signal. This is called scaling signal. This scaling signal value you have to decide. Circuit to circuit it will change. Don't think the scaling factor is fixed for particular for all applications. Scaling factor will change. This value, this gain will change based on the ratio of the each stages. If you know the ratio for the each stage, it is easy to calculate the scaling factor for particular system gain. So here for speed scaling factor, here gain is 2840. If you multiply 0.5 with 2840, you will get 1440 rpm, where 1440 rpm is the actual speed response in terms of digital platform, right? This is our controller. Our controller will start. So finally this 1440 you can take, you can compare with your reference nr star and actual speed, you can compare, then error is there, then you can send to controller, right? This is the way of deciding the scaling factor or gain value for the speed sensor. Now come to another important thing is, see, this is about RTA block. See, it is similar to MATLAB now only. Once you install, you need to install DSPACE software in your system. Then after that, you need to install MATLAB software. Then after installing MATLAB and DSPACE, you need to integrate the MATLAB with DSPACE software. Once DSPACE software is integrated to MATLAB, then you will get this block. What is RTI? RTI is nothing but real-time interface block is available. Whatever MATLAB you are using now, that is called offline. Once MATLAB is integrated to particular controller, then that is called real-time MATLAB. Now question is, what is difference between real-time MATLAB and offline MATLAB? Anyone from the participants? What is the basic difference between offline MATLAB and online MATLAB? Online MATLAB nothing but MATLAB is integrated to the any controller, then it is called online MATLAB, real-time MATLAB. If MATLAB is not integrated to the any controller, it is called offline MATLAB. What is the basic difference between offline MATLAB and online MATLAB, real-time MATLAB? Participants, this is very important point. You need to analyze so that you will get clarity about what is the significance of execution time. Why we are discussing too much about execution time in offline MATLAB, right? Once see, in offline MATLAB, you can even your program, irrespective of the length of the program, you can decide sample time. You can define the sample time irrespective of the execution time. But see, in real-time MATLAB, in online MATLAB, see, before deciding the sample time for execution, sample time is nothing but the rate at which your program is executed. Before deciding the sample time, you should know what is your execution time. Based on the value of the execution time, right? If execution time is 100 microsecond, you have to take sample more than 100 microsecond. Then only what will happen, after completion of every sample period, you can expect output of your logic. Otherwise, your controller will give error. Your DSPACE software, here you will get error, right? This, see, execution time, sample time, whatever sample time you are deciding, right? That sample time should be greater than your execution time. This is an important time, right? This is about offline simulation. In offline simulation, suppose this is your sample time. Within sample, you can complete your task, or within the sample time, your task may overflow in the next sample also, no issue. In offline, no constraint. You can take less sample or you can take more sample, no issue. It is not your MATLAB, it will not give any error. But in real-time MATLAB, once your MATLAB is integrated to the real-time controller, see, execution, this is about time for execution, right? You have to execute the program within the sample period. Then whatever output is there, after execution, you will get output. Whatever output parameters are there are available after execution, these parameters are acting as a initial parameter for next cycle. Without getting the initial parameters, right, we cannot execute the program. That's why this sample time is so important. Selection of sample time also will affect the performance of the system, right? So if you type in MATLAB command window RTI, you will get this block. In offline MATLAB, you won't get this block, right? Master, slave, right? So if you go through the slave processor, this PWM pulses blocks are available. Next, duty control blocks are available. Frequency control blocks are available, right? Slave input, slave output ports are also available. Next, if you go through the master PC, ADCs are available. ADCs, DACs are available. Encoder, we can adopt encoder also. Next, input port 20 IO pins are available. If you extract these blocks, only here your job is, see, you need to concentrate only on how to write your logic in MATLAB is so important. Once you write your logic, whatever procedure you are following for offline MATLAB, same logic here also, same logic. Only thing is, here in real time MATLAB, there is there is no power circuit in the real time MATLAB. In offline MATLAB, control circuit you have to give reference, and output of the inverter you have to, so output of the controller you have to give the inverter, then inverter you have to connect it to the motor. This is what we are doing in offline MATLAB. But in real time, see, up to here you have to do in real time MATLAB. You no need to concentrate on power circuit. Power circuit is there outside, physically it is available. If physical, see, through MATLAB we are aim is generating the pulses to the inverter. So up to pulse generation you have to develop the logic in MATLAB. Whatever procedure you are following in conventional system, same procedure you can follow, right? So writing the code and generating the pulse is a big task in the online MATLAB. So this is simple VBIF method. For understanding purpose, I have taken VBIF method, how to implement VBIF method in DSPACE software. See, simple. So this is our requirement, NR star, right? So if you integrate the speed, what you will get? You will get theta. This theta, right? This theta, using this theta, we can calculate A phase modulating signal, B phase modulating signal, C phase modulating signal. 3 sinusoidal signals we can generate with this magnitude. This is VM. Using theta m and VM, we can write program here. This is the simple program. By using multiplier, we can write program for modulating generation for A phase. VA equal to VM. This VM into sine theta. VB, this is the mathematical model for A phase modulating waveform. Simple. This is a very, see, sine triangle PW nothing but you need to generate the 3 sine signals, 3 sinusoidal signals, and these 3 sinusoidal signals you need to compare with high frequency carrier waveform. Can I ask one question, participants, before closing today's session? What is the significance of modulating waveform? What is the significance of carrier waveform? Here, this is about carrier waveform, high frequency. What it will decide? Through carrier waveform, what parameter we can control? Through modulating waveform, right? Through modulating waveform, what are the parameters we can control? Participants? So these two are under your control. Modulating signal and carrier waveform we can decide, right? This is a control block. This is a, please try to understand. This is complete. This is a real-time control logic we are developing. We are deciding the modulating waveform peak value, and we are deciding the carrier waveform frequency. We are deciding. Now, question is, what is the signal? What is the what parameter we can control through modulating signal? What parameter we can control through carrier waveform? Participants?
Magnitude and frequency.
Very good. Magnitude and
Frequency.
Frequency of what? Magnitude and frequency of?
Carrier signal.
No, magnitude and frequency of fundamental waveform. Fundamental signal. Whatever fundamental signal is applied to the motor or applied to the actual system, right? That fundamental signal, magnitude and frequency we can control through this is fundamental signal. Fundamental signal, magnitude and frequency we can control through modulating waveform. So by adjusting the modulating waveform, modulating waveform, frequency, time period, and magnitude. By changing the frequency, we can control the fundamental frequency. By changing the magnitude, we can control the RMS value of the signal. So RMS and frequency, both we can control through modulating waveform signal. By changing the frequency of the modulating waveform and by controlling the magnitude of the modulating waveform, we can control the RMS and frequency of the signal. Now my question is, why we need to control the RMS value? What is the significance of RMS in electrical system? What is RMS? Why RMS is so important for us? To do the job effectively, it required RMS. Am I correct or not? RMS is an effective value. RMS is so important if it is AC system. Average, if it is a DC system, average is so important. See, for understanding purpose here, I will take small example so that you will get more clarity. If you take simple chopper circuit, right? In chopper circuit, let us assume that this is our switching period. So what we are doing in switching period, this is on period, this is off period. So by changing the on period, duty period for particular switching period, what we can do, we can control. This is called average value. What about this one? This is called instantaneous voltage. Now question is here, output average voltage equal to duty into input voltage. This is the mathematical model for average output voltage. This equation is not applicable for instantaneous output voltage. Instantaneous output voltage is different. Instantaneous output voltage is, so from during on period, this value, this peak is completely depends on how much DC link voltage you are taking. During off condition, this value always 0 volts. Clear? Your instantaneous voltage is always regulating from VDC to 0, but average value is depends on what is the duty period of the switch, will decided by the average signal. Now practically all systems are, all systems are depending on, all systems will respond for average value. Let them that our system is a motor speed, steady state speed is decided by the how much average voltage you are applying across the motor terminal through power semiconductor is so important. Speed will not regulate. See here, during this instant, input voltage is VDC. During off condition, voltage becomes 0. Don't think your speed will come to 0 if you apply 0. Speed will not respond for instantaneous value. Speed will respond only for average value. That's why average and RMS, these two are called effective value. If you want to do any job effectively, right, you need to take care about RMS and average value. Average is so important for DC systems to do the effective job. RMS is so important for AC system to do the job effectively. That's why these two signals are called effective values. Effective values nothing but, see, with effective value only we can do job. Based on the RMS, your steady state speed will decide. Clear? Anyone having doubt? Participants, anyone having doubt? Clear? So here finally,
Sir,
yeah,
so sampling time is important for the controller, right, sir?
yeah, sample time is so important here.
Sir, in case of ADC, we'll be having a sampling time. Whether we need to keep different sampling time for current controller and speed controller?
No. We cannot maintain different sample time for different stages. So once you take your control block in window, see, for all blocks, sample time, execution time is decided by your modulating settings. So see, let us that, see, if number of instructions are more here, this logic is simple, VBF method. Here what we are doing is, based on the customer required speed, here we are deciding what is the magnitude of the modulating waveform, what is the frequency of the modulating waveform, we are deciding. As a electrical scholar, speed we can meet based on the customer requirement through voltage and frequency only. We don't have any option. That's why based on the required speed, here we are deciding this gain will decide the peak value of the modulating waveform. This operator will decide the frequency of the time period of the modulating waveform. So using magnitude and frequency, we can control the torque generated by the motor for particular system. Now thing is, scholars they are thinking that this is the mathematical model for speed sensing, right? So for speed sensing, if you want to use sample time 100 microseconds for modulating waveform generation, for pulse generation, if you want to use 10 microcontroller, it is not possible. There is only one option is available in DSPACE controller. Only one, there is one only single time you have to define what is sample time. For all blocks, sample time is unique. That's why we should not take unnecessary blocks in the MATLAB. If you take more number of unnecessary blocks, even if you take more number of scopes also, what will happen? Computation time will increases. If computation time is increases, sample time you have to increase. No option. Clear? You got my point?
Yes, sir.
So unique sample time only. You have to define unique sample time based on execution time, nothing but it is a time taken for completing the task for all blocks. How signal, this is the input signal, so finally this is the output signal. So how much time is taking to complete the process? This one, there are multiplier is there, here integrator is there, here sine function trigonometric equations are there, multipliers are there. This is the flow of signal. This is the flow of signal converting from input to output to generate the pulses. This is the sequence. In this direction, how many operators we are using, it is so important to minimize the execution time. If number of stages are more, number of mathematical operators are more, definitely execution time is increases. That's why by taking less number of samples, to minimize the sample time, right, you have to minimize the execution time. If you want minimize the execution time, you have to write the program with less number of mathematical operators, so that we can improve the performance of the system through minimum sample time. So finally, see, simple. So by using this IO pins, we can extract the pulses, we can extract the SA, SB, SC through the, so whatever panel we have discussed, through these panels we can extract this is the input output pin. So once you execute your program, then here signals are available, SA, SB, SC signals are available. These three signals you have to take complementary. So by taking complementary, finally SA dash, finally total 6 signals plus 1 ground pin. Why ground pin is so important here? Why ground pin is required? Here there is a 1 ground pin is there. So total 6 pulses plus 1 ground pin is so important to supply this information to the inverter. Whenever you want to transfer the signal from one circuit to another circuit, you need to take common grounding between the control circuit and power circuit. There is no common grounding, we cannot transfer the signal. If you want to transfer the information, it required common grounding. Zero potential point is required, common grounding is required, so that we can transfer the signal effectively from one circuit to the another circuit. That's why, so see this 6 pulses we can apply to the inverter, so that your inverter will obey your order. No option, there is no freedom for the inverter. So inverter will control the RMS and frequency based on your required speed. Then within short period, definitely your system will come to your required speed. This is a simple procedure. See, please try to understand. Implementing logic in DSPACE, many scholars they are thinking that it is a complicated. It is not a complicated. Important thing is, see, to understand this one IO pins, what are the IO pins, how to access this bit in, bit out. If you go through the data sheet, see, it is very easy. It is a very at what physical pin we can access this pulse, you will get clarity. Your data sheet will provide the information about see, if you take a master bit out 1, right, in simulation, physically at what pin you will get actual signal. You will get more clarity if you go through the data sheet. This is about data sheet of this DSPACE 1104, right? So if you take channel 1, physically this pin 2 will give the information. Here this is all about channel numbers, right? If you activate channel 1, physically you can get the pulse with respect to pin 2. It is
Vinay sir,
simple.
there are some questions out there. Can you take questions?
Anyone having questions?
Chat box.
My for systems with the power converters, how should we select sample time? See, sample time you should not select. Sample time is decided by your logic. How much logic? See see, if your logic is so complicated, definitely you have to take more sample period. Clear? Anyone having doubts? Participants already time is 10 minutes extra. Anyone?
No, half an hour extra, 40 minutes extra, Vinay sir.
Sir,
Sir,
my slot is
hello.
up to
No issue.
4:30.
Four.
Hello.
4 only.
Sir,
Oh, sorry, sir. Actually, I thought 4:30. 2:30 to 4:30.
Okay, Vinay sir. No problem.
Shall
There
I
is a
stop
doubt.
here?
Amarendra, Dr. Amarendra
Yeah,
sir.
yeah. Yes. This is Dr. Amrita. I have small question on this
Sir.
presentation, sir. When you are giving this output pins, like suppose I suppose this is a 3-leg inverter circuit might be you are given. When we are defining a complementary from upper switch to lower switch, we have to insert a dead band. When we defining a dead, when we define a dead band, it could,
Okay, you can continue.
When we are going to define a dead band, it could be like a 1 microsecond or in terms of nanoseconds, right? But in the real time, it is saying it should be minimum 1 sample time. So that error creates definitely. We cannot work out directly the dead band from upper switch to lower switch with the DSPACE controller. Is it possible to 1 microsecond inserting delay between upper leg switch to lower leg switch?
Sir, actually, practically, this deadband circuit, this one is completely depends on how much delay you need to provide between top and bottom. Depends on what is the energy levels of your actual system. If inductance effect is more, right?
No, that is correct, sir. What my question is, deadband is on average it is a 1 microsecond, and somewhere it is averagely
we are taking 4 to 5 microseconds.
Okay, 4 to 5 microseconds. But as per my working experience, this DSPACE having minimum sample time around 10 microsecond to 20 microseconds.
No, sir. In our case, our sample time, whatever 10 microseconds is very good, but our logic is working only for 100 microseconds.
When I try to insert a delay of 4 microseconds or 1 microseconds in the complementary signal, it is giving error such that it has to give minimum 1 sample time. If minimum 1 sample time is a 40 microsecond, I cannot insert the delay of 4 microseconds in the complementary signal.
Yeah,
that is a big problem. I have wasted 6 months time for that.
Can I provide solutions?
Yes.
So what is my suggestion is, say suppose your execution time is actual sample time is 40 microseconds. Suppose if you want introduce 4 microseconds or 1 microseconds for deadband circuit using complementary circuit in DSPACE, it is not possible, sir.
It is not possible, correct.
That's why you have to develop own analog circuit outside, right? Correct. So that by using analog circuit, we can provide 4 microsecond deadband circuit. Correct. See, in simulation here, if you go through it here, there is no deadband between
there is
SA
no
and
deadband.
USB.
Practically, we have to insert a deadband.
So Semicron, if you contact Semicron people, they will provide deadband circuit also. There are so many suppliers are available in market. They will provide deadband circuit directly. You no need to design also. You no need to spend time also. Clear? They will provide, sir, deadband. If you want 2 microseconds, they will design the 2 microsecond deadband circuit. Outside you can keep.
Correct. Ultimate solution is final external analog circuit.
External only, sir.
Okay. Correct, sir. We only done. We are after 6 months we get solution of that one.
Okay.
we done this one
Actually,
in 4 years back.
Shivkumar sir,
Yeah.
I thought up to 4:30.
No problem. No problem, Vinesh sir. Thank you very
Sorry,
much.
sir.
Thank you.
Okay.
Thank you.
Anyone having doubt, you can